Good morning, everyone. You are welcome in AI with Rao, and let's make AI simple. So, in this journey, in seventh day, we have another algorithm that is called decision tree. And in this algorithm, we are going to cover these four topics: that how it works, how it picks the right question, why it follows a tree way to answer the question, and what are the drawback underfitting, overfitting. Okay, so let's start and finally come with one liner that a decision tree is a series of yes or no question, like you have played 20 questions game, right? And it follow the answer, and at the end it will give you the final decision. So let's start with the story, the way you do and also we do is you ask your friend a question that is it an animal. Okay, this is the first question. They will give you answer yes or no. Then you will ask, is it bigger than cat? They will say yes or no. Then again you will ask, does it bark? Then they will say yes or no. After these three questions, you will come to conclusion that what this animal is. Now this three stage, how smartly you ask this three question defines that what answer you will get and how perfectly you will get. You got my point? Now let's discuss the real term with a story, another story. If I ask you a question that is it raining? First question I ask. It has two answers. First is yes and second is no. If you say yes, then my answer is play inside. So this is the final answer. This is the question and this is the answer. Now if you say no, then my another question is it too hot? Then you have answer. And what are the answers? Again, yes or no. If you say yes, then my suggestion is stay inside. And if it is no, then play outside. Now you got the point. 1, 2 question. These lines are answers and these are the final outcomes. What it is called in machine learning term. So these box are the features, the questions that I'm asking. Is it raining? Is it hot? Is the feature. Okay, the lines are the branches, they are called answers that you provided, and the final is the final decision, like the leaf. In plants, the leaves are the end point. After that there is nothing. So that's the reason. You can see after that these are the leaves. Why they are leaf? Because after that there is nothing in the tree. These are the end points. Now you understand the terminologies. Now let's touch the real magic. Is these, I can tell you this tree base is very versatile and it works for both, like for classification and regression. In classification it has yes or no, we have already discussed that, and in regression we perform on number. So it works on also yes or no situation and on number as well. Now this is the real you say the use case. So you have two type of balls. In the left side you can see, if I ask you how smartly these balls are segregated. In the left side you can see some balls are orange, some balls are blue, and they are intermixed. So this is a bad split because they are intermixed. What is a good split? Where left side we have completely one type of ball, that is orange ball, and in the right side we have completely different type of ball, and that is blue balls. So this is a good split. So what does it says? That a tree does not guess questions randomly. At each step it tries possible questions and pick the one that separates the group the best possible way. What is a good split? One side is mostly a spam and other side is not a spam. Like it is deciding a spam or not, but we are discussing about orange and blue balls. Okay, now the question comes is, on what parameter, on what measurement, and what decides that this is a good split and this is a bad split? And for that there is a term called Gini, or it is also called entropy. If you forget the name, no issue, but Gini is a very popular name. Okay, so we will discuss that. And it measures how mixed up the group is. It measures the degree of mixing. How mixed the group is measured by one quantitative term that is called Gini. Got the point? Now, why everyone loves decision tree? We will cover that what is Gini and how it is being measured with another example. The other concept that you need to know, and this is like a advantage and disadvantage, that why everyone loves this decision tree is because you can see the logic. You can print the entire decision tree and you can like check that why it is giving like this. And this is a huge advantages for this, because it builds the trust. If your boss asks that why you did that, you can directly give the logic, and it gives, and that's the reason it is being used in banks, doctors, courts, everywhere. And there is no fancy prep needed. Directly you can do that. It's very simple, and this is fast and simple as I mentioned you. So that's it. And it has given an example that like if I ask you, should I reject this or accept this loan, and you say no, it is rejected. Now your boss will ask why you rejected it, what is the logic. You can directly print and show him that this is the logic, that his earning is less than 30,000 and has no credit history. So it creates accountability. You got the advantage. Now comes the two drawback. These are the end points, because the question you are asking, okay, and you are getting the answer. But if you ask 200 questions and then if you are giving the answer, then what is the logic? What you learn? You just memorize that. So this concept is called too deep. You just memorize. If you just in the beginning you supposed to give the name of the animal and you ask 3 questions, but suppose you ask 200 questions and then you are giving the answer. Is it a game? No, you have just memorized that. But instead of guessing the animal, if another situation comes, you will be blank. So this is called too deep and you will just memorize that. If you have to encounter the real situation that is completely different, because you have not learned the pattern, you will scramble. And this is silo tree, very simple rule. So if you are asking only 2 questions and you are just giving wrong answer. But what we want in between, okay, and that is right generalization, where you will learn the pattern. Here U means the model, okay. So this is called too shallow and too deep. There is a term for that. If it is too shallow, underfitting, okay, it is too deep, this is called overfitting. Simple. But the problem is, okay, we have underfitting and overfitting, but what is the right fitting? So right fitting is a generalized rule that you can fix the depth of the question that you want to ask. We fix that, okay, 5 depth, 5 sequence of question you can ask, series of question ask, not more than that. After that you will not learn the pattern, you will just memorize it. Okay, now let's end everything and jump directly into the code. So what we have done, we have imported decision tree classifier model and we provided the depth. Okay, now we provided the data X train and Y train, feature and label. Okay, now we trained our model. After that we will provide another that predict with this income, this age and this credit. Should this person be granted a loan or not? Now it will learn from 5 depth of questions. Okay, the best part, you can directly like export the whole model and understand the whole decision tree if and else loop that it is using. It is so much good thing for everyone who is working. They have accountability that why I took such a certain decisions. Okay, now this is something that will completely clear all the shadows that you have in your head with this example. We are going to take one example through which we will cover everything that previously you are not able to relate. So we have this bucket. One bucket have this only orange balls. Second bucket have 3 orange, 3 green balls, and in the third bucket we have 1 green and 5 orange balls. And as I have told you that we have a coefficient called Gini. So through Gini we will measure how much the degree of their group splitting. Okay, so here if it is completely pure, then Gini is 0. If it is mixed equally, then Gini is 0.5, and if it is less, then 0.28. Now we'll ask what is Gini and what is the formula. Here it is. You can see right now I have explained you this. Now come to this formula. Here the formula of Gini is 1 minus chance of orange and chance of green and square it. Chance means what? Probability of getting an orange ball and probability of getting a green ball, and the square. Now in this box, how many balls are orange? 3. And how many total balls? 6. So 3 by 6 is what? 1 by 2. Now the formula is 1 minus square of their probabilities. That's it. So 1 minus half square minus half square, that is 0.5. So it will give that what is the degree. Now here is the formula. Very simple. I'm not writing complicated one. Now this is for the second type of ball bag. Now for the first one where all oranges were there, how can you find the guinea? 1 minus, how many oranges are there? All orange, so 1, 6 by 6, that is 1. And how many green ball? No, 0 by 6, so 0, so that is 0. So guinea we will get guinea as 0. It is completely pure. Now for half, just we found 0.5. Now this question comes that why we are squaring? Why not 1 minus probability of orange ball minus probability of green ball? The reason is it completely like it rewards the basket that lean heavily one side. One color, okay, big square root, greeny drops to 0 fast. What point? So it just favors certain condition, and that's the reason we have squaring to the place. Okay, this is the diagram, and how the quality of question in decision tree matters. So we have these balls, they are mixed. Just one question, is it orange? Completely pure. Now you can understand, a good question turns a messy basket into two clean ones. That drops mess, information gain. The drop of this messiness. What is messiness here? Everything were 50-50, completely mixed, completely messy. One question that completely transformed the whole picture, and now we have orange separately and green ball separately, and this term is called information gain. You can see right now, just one good question and the degree of information gain is completely like you can't even imagine. So if you let the tree keep asking question forever, it makes a tiny basket for every single ball, one ball per basket, and that's not learning, that is memorizing. You got this point? What does it mean? So we have 3 orange ball and 3 green balls. If I ask series of say 100 question, and at the end every new basket has only one type of ball, then what is the learning? It is the memorizing, that as many ball, as many basket, then there is no pattern learning. So this is called memorizing. You got this point? So this is the drawback that we discussed. We will discuss about overfitting and underfitting in coming videos in more depth. And now come what the topic we have discussed so far is a decision tree, what the game it plays, 20 questions game of yes and no. That's it. And now it picks each question, split that data into cleanest form, and its superpower, you can read exactly why it decided. You know, the truth, the accountability, you can read the whole tree. And it works on both category, for like yes or no and for number as well. And we discuss about what is underfitting and overfitting. So thank you so much for being in the video till now.